everybody, hope you're having a great weekend. I know that some of you have started moving into the next section, which is the section on z-scores, and I think you're going to have a lot of fun in that section. But before you move on, I want everybody just to sort of think back about the section that we just did on standard deviation and variance, because there are some key terms that you've learned in that section which are going to come up again, particularly when we get to the unit on the analysis of variance. So one of the things that you learned is how to calculate the sum of squares, which if you say that in its full terminology is the sum of squared deviations. And if you say it that way, it should tell you exactly what the formula is, because the definitional formula of the sum of the squared deviations says you calculate a deviation, and I'm doing it like this to be parentheses, so a deviation is x minus the mean, m or mu. You calculate a deviation, and then you square all of those for all the scores in the sample or the population, and then you add them up. You take the sum of them. So the sum of the squared deviations. Okay? Now that term is going to come up a lot when we get to analysis of variance. So is another term, which is if you take the sum of squares and you divide through by n for a population or by n minus 1 for a sample, you get the variance. Well, another term for variance, another way you could think of it is that is the mean of the sum of the squared deviations, which will be abbreviated ms. And we're going to come up to that a lot in analysis of variance. So you've learned SS, sum of squared deviations, or sum of squares. You've also learned mean squares, but we've called it variance. Okay, so the variance is the sum of squared divided through by either n or n minus 1. Now, if you want to get to standard deviation, you have to take the square root of all of that, because remember, we squared the deviations. So when we squared the deviations, we made that distance measure bigger than it really is. We inflated it. And the reason we did that, of course, was to get rid of the sign. But once we're ready to get standard deviation, we have to take the square root so that we get rid of that, that increase or inflation in the measure. So that's it. Just sort of a recap. Hope you had a great weekend, as I already said, and have fun with z-scores.